Hello, welcome to the Argo course. My name is Mohammed and I'm very happy to be here. In this session, I want to talk about sync phases and sync waves. But what are them? Why do we need sync phases and sync waves in Argo CD? Okay. Argo CD executes and deploys all the resources in Kubernetes cluster based on priorities. We have multiple priorities in Argo CD to deploy the resources, and Argo CD examines all of them in order. The first and the most important priority to deploy the resources in Argo CD is sync phases. But what is that? Argo CD executes a sync operation in a number of steps. At a high level, there are 3 phases in Argo CD. The first phase is pre-sync. The second one is sync. And the last one is post-sync. These are 3 phases in Argo CD. All the resources are in sync phase by default. We can change the default behavior of Argo CD, and we can place a resource into another phase. But by default, all the resources are in sync phase. First of all, I want to talk about pre-sync. For example, we want to perform a database schema migration or check the health of the application or anything else before deploying a new version of the application. So we define a job, for example, and place it in pre-sync phase to execute before sync phase. So we have a job here, for example. Health check of the application. Health check of the application. Very good. Let's remove that. We don't need it here. Okay. We have a job. This job can be a health check job or a database migration job or anything else. But we use its job in pre-sync phase to deploy before the sync phase. Okay. We can run or multiple resources in pre-sync phase, and Argo CD will run the pre-sync phase first, and once the pre-sync phase complete and all the resources in that phase become healthy, the sync phase will be run and the resources will be deployed in the cluster. Very good. But what about sync phase? In this phase, we have our resources. For example, we have our service, SVC. We have, for example, service account. We have deployment. These are the resources of our application to be deployed. These are in sync phases. But what about post-sync? Another phase is post-sync. For example, we are going to send a notification to a chat ops service like Slack or Mattermost or any other services to inform users that the result of the last sync was okay. So we define a job, for example, and place it in post-sync phase. It will be run if sync phase complete and all the resources in that phase become healthy. If sync phase fails, post-sync phase won't be run. This is so important. So we have a job, for example, here. Okay. These are the main phases in Argo CD. But we have another phase in Argo CD. Also, we have another phase called sync fail phase. It executes when the sync operation fails. For example, we send a notification to inform users that the result of the last sync was failed. But how can we define the phases of the resources? We use Argo CD hooks. These are the Kubernetes annotations. So if we want to place a resource, for example, into presync phase, we use our Kubernetes annotations called Argo CD hooks to define and to place a resource into a specific phase. For example, I want to place this job in post-sync phase. Because of that, we use a Kubernetes annotation called Argo CD hooks to place it into this phase. Very good. So the another phase was sync fail. Very good. Okay, let's go to the presentation. I want to show you how Argo CD sync phases work and how can we use Argo CD hooks as Kubernetes annotations to define the phase of any a resource in Argo CD. Very good. Okay, this is the Git repository of our course called Argo CD-tutorial. I want to use this directory here, Argo CD sync phases and waves. We have two different directories that I want to show you. The first one is sync phases waves manifest examples. Let's go to it. In this directory, we have multiple files. We have multiple resources and manifests. As you can see, let's go to deployment first. As you can see, we have no annotations in this manifest about Argo CD hooks. So it means that this resource will be run in sync phase by default. But what about the other resources? This is a resource job. This is a resource called fail job. It has no annotation about Argo CD hooks, and this is true about the other resources. So it means that all of these resources will be run in sync phase by default. So I don't want to do that because it is not the desired state that I want. In this scenario, I want to use a pre-job to monitor the health status of our application. If the application is healthy, we can deploy the new version of our application. And after that, I want to send a notification to a chat ops service called like Slack or like Mattermost. But in this scenario, I want to use Mattermost as the chat ops service to receive the notification. I want to send the notification to Mattermost to inform all other users about the last sync result. And if sync operation fails, I want to use a fail job to send a notification to a chat ops service called like Mattermost to inform all the users about that sync operation fails and the last sync is sync failure. Okay. We have a deployment. I want to use it in sync phase. It is the part of the application, so I want to place it in sync phase. We are not using any annotations about Argo CD hooks, so by default, this is in sync phase. Another resource is fail job. But before that, I want to explain pre-job. Okay. As you can see, the kind of this manifest is job. And the name of this resource is health check pre-job. Its image is curl images/curl. We are using curl command to check the health of our application. This is the address and port of our Mattermost server. You can use any other addresses here. You can use the address of your application here. This is a template only for this session. It's just a template for this scenario. So the application here is the Mattermost because we prepared a Mattermost server before this session. As you can see, this is our Mattermost server. I highly recommend to use Mattermost or Slack or any other services to receive your notifications about your CI/CD pipelines. It can help you a lot, I think. We are using this service in our organization, and it's very good. So this is the address and this is the port of the Mattermost. So in the pre-job, we are monitoring this application and we are monitoring the health status of this application. If the health status of this application is okay, it returns a message called Mattermost is up and running and exit 0. It returns a status code 0. And if the health status of the application is not okay, it returns the message that Mattermost is not accessible, and then it returns 1 exit status code. This is our pre-job. So if our application, I mean Mattermost, is up and running, the pre-sync job succeed. And the sync phase will be run. But if this job fails, the sync phase won't be run. This is so important. Okay. We are using service and service account as the part of our application. So we don't want to use any other Argo CD hooks annotations here. But what about pre-job? I want to use this job as our pre-job. So because of that, we have to define an annotations here called annotations. and I type argo city dot argoproj.io/hook equals presync. It means that I'm changing the default behavior of Argo City. I want Argo City to run this job in presync phase before deploying our application, because we are using an annotation called Argo City hook and the value is presync. Let's commit it. Add presync annotation to prejob.yaml. Add presync annotation to prejob.yaml. Very good. So this manifest and this resource and this job will be run in presync phase before sync phase. And if succeed, sync phase will be run. And if fails, the sync phase won't be run. Okay. But what about post job? We have another job. We have another job here called Mattermost post job. I want to use this post job to send a notification to our Mattermost service to inform the users about the last sync result. The post job will be run if sync phase complete and all the resources of that phase become healthy. So it returns a message from Argo City. The last sync is sync OK. We are using multiple environment variables here. What are them? We have another directory. We have another subdirectory into the main directory called Python Mattermost API. I wrote this script to connect to our Mattermost service, to connect to this service and send a message to a channel. But what is the channel? In Mattermost, we have two specific words, team and channel. We have a team, and into that team, we can have multiple channels. For example, we are using a team called DevOps-hobbies. This is a team. And into this team, we have multiple channels. We can create another channels here. For example, create new channel. So in this team, we can have multiple channels. One of these channels is Argo CD-course. I want to send the notification of Argo City to this channel, Argo CD-course. And the name of its team is DevOps-hobbies. For example, you can create a channel called staging to receive the notification about the deployment applications of your staging pipeline. For example, you can have a separate channel called operation or production to inform about the deployment of your application and in production pipeline or anything else. Okay? Because of that, in this script, we are using channel name and team name. And each channel has a channel ID. So I want to send a notification to our Mattermost server using these two items, channel ID and the message. But we are using environment variables. We don't want to use any static information here. We want to use environment variables to change the values if we want. Because of that, we are using these environment variables in our job to override these environment variables here. Environment port, for example, this is, if I change the value of this port, it will override here. And this is true about the other environment variables in this script. Because of that, we are using these environment variables in this job. I want to use this URL. This is the URL of our Mattermost service. This is the URL here. What about token? This is personal access token in Mattermost. If you want to use this script to send a notification to your Mattermost server or service, you have an account called, for example, DevOps-hobbies. If you click on Profile and if you click on Security, the second item and the second option is Personal Access Token. You can create a personal access token and use that token here. This is the personal access token of DevOps Hobbies user in Mattermost. This is disabled by default. Using personal access tokens is disabled by default in Mattermost. If you want to enable it, you can click on System Console. Let's scroll down here. We have integrations, integration management, and the last option is enable personal access token. This is false by default. You can click on true and save, and then you can use profile, security, and personal access token to create a token. I created a token already, so I'm using the token here. We are using HTTP, the port is this. The channel name is Argo CD-course. This is the channel name, Argo CD-course. And this is team name, DevOps-hobbies. This is the team name. We are using this team and this channel to send the notification to this channel. These are the variables of Mattermost post-job success. So this job will be run if sync phase complete and all the resources in that phase become healthy. Very good. Okay, I want to use this. I want to run this resource after the sync phase. Because of that, I create an annotations here called Argo CD argo-proj.io/hook equals post sync. Very good. Let's commit it. I type add post sync annotation to post job.yam. Add post sync annotation to post job.yam. Very good. Refresh it. Okay. We have another file called fail job. This job and this resource will be run if sync operation fails. Because of that, here we have another message from Argo CD, but in this time, the last sync is sync failed. This message will be sent to this channel in Mattermost. And the environment variables that I explained in post job exist here. URL, token, port, channel name, and team name, but the message is different. Here, the last sync is sync failed, as you can see. But in post job, we are using sync OK because post job runs if sync operations succeed. Okay. Because of that, we use the annotation here, annotations, and argo cd.argoproj.io/hook equals sync failed. Okay. Add sync fail to sync fail job.yaml. Fail-job.yaml. Yes. Add sync fail annotation to fail job.yaml. Very good. So we are using 3 different jobs. This job, fail job, will be run if sync operation fails. Because of that, we are using sync fail. Another job is post job. This job will be run if sync operations succeed. Because of that, we are using post sync. And another job is pre-job. This job will be run before sync phase. Because of that, we are using pre-sync. Very good. Let's create an application here. We have an application here called app-1.yaml. The path that I want to use is this. Because of that, I copy the path and paste it here. Okay. The repo URL is true and app sync phase -1, yes, because we may want to create another applications about sync phases. And also we are using sync options create namespace equals true, so we don't need to create this namespace by default. Argo CD creates this namespace first and deploys our application. Okay. Let's save the file and let's apply it. And the application has been created. We are not using autosync. You can use autosync if you want, but in this scenario, I didn't use that. But you can use it. It doesn't matter. As you can see, we have 3 different resources: deployment, service account, and service. Service account, service, and deployment. The other resources are in another phases and are in different phases: pre-job and pre-sync and post-sync. Let's sync the application and how Argo CD sync phases work. Please attention here. I click on sync and click on synchronize. As you can see, the first resource is health check pre-job. Health check was successful. And we are in Mattermost post job. The post job was successful and the last sync is sync OK. But what was the process? The first process was health check. It was the pre-sync. the presync was successful. So sync phase runs. And sync operation was successful. Because of that, the post sync phase was running and it was successful. Let's go to our Mattermost server, and as you can see here, we have a new message here called message from Argo CD, and the last sync is sync OK. Very good. If you want to see the order of deployments of these resources, you can click on sync OK. In the result section here, we have namespace first. The namespace app sync phases 1 created. Argo CD created the namespace first because we used a sync option here. Create namespace equals true. The first resource and the first manifest that Argo CD deployed in this path was health check pre-job. As you can see, the hook is presync. So it was the first resource that deployed in our Kubernetes cluster. And then Argo CD deployed our resources in the sync phase. Service account, service, and deployments were in sync phase. And the last resource that Argo CD deployed was this job, Mattermost post-job success. And its hook is post-sync. Okay, it was about the order of the deployment of these resources in Argo CD. So this is the first job, presync. These are in sync phases, and this is in post-sync phase. Very good. Let's go to our Git repository. In this time, I want to talk about a sync fail phase, and I want to show you how it works. But before that, let's change this address. This is our pre-job, and this job is responsible for monitoring our Mattermost server health status. But instead of Mattermost address, I want to write a very simple Python Flask application to return a message on the web page. For example, application is running. And we will use these exit code status, exit 1 and exit 0, based on the return message from Flask. Okay? Let's do it. This is our Mattermost server terminal. And I want to do it in our Mattermost server. Because of that, I create a file called app.py. I type from Flask import Flask app equals Flask name slash app dot road def message, and here return h1 application is running. Very good. And here if name this Python Flask script will be return a message. This message application is running. Very good. Let's save it, and I type Flask run. Let's run it on all the addresses of this server. -- host. Okay. And here, if I type the IP address of Mattermost server, as you can see, it returns the message called application is running. Very good. Let's change this script, and let's change this address here. The default port of Flask application is this, and I want to search for this word, running. As you can see, it returns a message called application is running, and this sentence has a word, as a specific word, running. So when we are using curl, it will search for this specific word called running, then echo application or Flask. Flask application is up and running, else Flask application is not accessible. Very good. Let's commit it. Okay. In this time, I want to test sync fail. But before that, because of this change, I want to redeploy and resync of this application to test it's working or not. Let's sync it. As you can see, health check was successful, and Mattermost job is successful too. So if I go to Mattermost server, as you can see, we have another message from Argo CD, and the last sync is sync OK. The health check was successful because in this server, in this address and in this port, we have a message called application is running. But what happens if I change the message? For example, let's imagine that my application has been down. Because of that, I want to change the message from application is running to application is down. And if I refresh this page, debug mode, what is that? Application is down, very good. Okay. We now have a new message called application is down. So what happens if I sync this application again? As you can see, we have another job called fail job. This job will be run if sync operation fails. Because of that, let's go to Argo CD dashboard UI, and I want to sync this application again. As you can see, the health check status is failure. Let's open it. And as you can see, we have a message, Flask application is not accessible. And here, this is so important, we have another job, Mattermost post-job failure was running. If I click on it, you can see that, yes, we have a new message here, but in this time, instead of sync OK, we have a new message called sync failed. If I click on sync failed, in the result section, we have only two resources that were running. The first job was presync. The result of this job was failure. Because of that, the only resource that was allowed to run was sync fail job, sync fail phase job. Because of that, this job was running, and this status is succeed, because we have a new message here called sync failed. Okay, we talked about all the available phases in Argo CD: post-sync, pre-sync, sync, and fail-sync. And I try to present you with a scenario with this Mattermost server and with a Flask application. Okay, very good. Okay, in this time, I want to talk about hook deletion policies. But what is that? We have three different types of hook deletion policies in Argo CD. I want to show you something. Let's go to our cluster. I type kubectl get ns. We have a namespace called appSyncPhase. What is that? This is the namespace of our resources that you can see here. Our jobs, our deployment, our service account are using this namespace. Very good. I type kubectl jobs-n appSyncPhase1. As you can see, we have three different jobs, and these jobs are available in our Kubernetes cluster. This is the pre-job, this is the sync fail job, and this is the post-sync job. We can use the hook deletion policies to delete these hook resources. These are our hook resources, because in these manifests, in these resources, we are using hook annotations. So these are our hook resources. We have three different hook deletion policies in Argo CD. The first policy is hook succeeded. It means that the hook resource is deleted after the hook succeed. For example, my pre-job was succeed, so it will be deleted from our Kubernetes cluster if it uses this annotation, because it was succeed. The second policy is hook failed. It means that the hook resource is deleted after the hook failed. For example, in this scenario, we have a pre-job called health check, and this job was failure. So if this job uses hook fail deletion policy, this job will be deleted from our Kubernetes cluster because it was failure. And the third one is before hook creation. I type it here, before hook creation. But what is that? It means that any existing hook resource is deleted before the new one is created. Okay? It will be available until the new resource will be created. And I want to note that the default hook deletion policy of the resources in Argo CD is before hook creation. As we said earlier, the default sync policy, the default sync phase is sync, and the default deletion policy of our resources is before hook creation. Because of that, these resources are now available in our Kubernetes cluster. Okay, I want to change the default behavior of some of them. Because of that, first of all, let's run our Flask application again. I type it, I refresh the page, application is down. Let's change the message from down to running. Okay, application is running. Okay, in this time, I want to define hook deletion policies for my 3 jobs. For example, I want to define a hook succeed deletion policy for this precinct job. I type argo CD dot argoproj.io slash hook dash delete dash policy equals hook succeeded. Hook succeeded. Okay. I type add hook deletion policy to pre-job.yaml. This job will be deleted from Kubernetes cluster if its result sync, if its sync result was succeed. Let's deploy this application and let's sync this application again. It was sync failed. Let's delete this application to create a new one to avoid any conflicts with the previous syncs. Because of that, I type kubectl apply-f app.yaml. I click on sync and synchronize. Health check was okay. Our resources have been created and the post-job success was succeed. And we have a new message called sync okay. But what about the status of these jobs? Let's type it again, kubectl get jobs. As you can see here, we have no jobs about pre-job. The health check pre-job is deleted from Kubernetes cluster because it's using hook succeed deletion policy. It was succeed because of that it has been deleted from Kubernetes cluster. Very good. And this time I want to change it to hook failed. If this resource is failure, its job will be deleted from Kubernetes cluster. Else, it will be available in our Kubernetes cluster. Because of that, first of all, I want to resync our application to see that it will be available in our Kubernetes cluster because its deletion policy is hook failed. If hook succeed, so it will be available in our Kubernetes cluster. Let's sync this application again. Okay, health check. Health check is okay. If I go to terminal and if I type it again, you can see the health check pre-job is now available in Kubernetes cluster because of that. Because the health check pre-job hook deletion policy is hook failed. Let's fail this job. Because of that, I type it here. Application is down, for example. Yes, and let's resync our application and it will be failure. I think that I have to delete this application again to avoid any conflict. Okay, app sync phase 1, deleting, and let's apply this application again. And if I click on sync, the health check is failure, as you can see here. And as you can see, there is nothing about pre-job here. It has been deleted from Argo CD dashboard UI 2 because it was failure and its hook deletion policies is hook failed. And if I type it here again, you can see that the pre-job has been deleted from Kubernetes cluster 2. Okay, it was about hook deletion policies in Argo CD. Hook succeeded, hook failed, and the last one was before hook creation. And the default hook deletion policy is this, before hook creation. Okay, let's talk about sync waves in Argo CD. But what is that? Let's back to the note. As we said earlier, the first one and the most important priority to deploy the application in Kubernetes cluster is phases. Argo CD will look at the phases first to deploy the application. In this example, Argo CD will run presync phase first. It has a single resource called job, and it will be run. If it is succeeded, the next phase will be run. The next phase is sync phase. Presync has a higher priority than sync. After presync, the sync phase will be run. In this sync, we have three different resources: service account, SVC, and deployment. The phase of these resources are mutual. They are using sync as their phase. So what happens? Because they are using the same phase. In this situation, Argo CD will go to the next priority. The next priority is wave. Wave is a number. It's not a string or anything else. It is a number. Wave can be a negative number, for example, -1, -2, and blah, blah, blah. Can be 0 and also can be a positive number, +1, +2, and anything else. So wave is a number. Each resource, as I said earlier, each resource has a default phase. The default phase of all resources is sync. And the default wave for all the resources is 0. So all the resources have a default wave called 0. So they are using the same wave number. Very good. But in this time, I want Argo CD to deploy SVC before service account. In this order, as you can see, SA first, then SVC, and then deploy. This is an example. This is just an example. But in this situation, I want Argo CD to deploy SVC before service account, like this. SVC first and SA or service account as the second resource to be deployed. Because of that, we have to change the wave number of each resource. The lowest number has the highest priority. For example, -10 has a higher priority than -2. -7 has a higher priority than 0 or +1 or anything else. So the lowest number has the highest priority. Because of that, I want to define a sync wave with this number. For example, -3 or -2 or -2. I want to deploy service account as the second resource. For example, it is 0, but I can change it to -1, for example, and then deploy if the default wave number is 0. In this situation, SVC will be deployed in our Kubernetes cluster as the first resource in the sync phase, not in all the process of deployment. In the sync phase, SVC will be run as the first resource, and then Argo CD will go to the next resource, service account, and the last is deployment. So this is about sync waves, the order of deploying the resources into a specific phase. Okay, let's go to present this section. Okay, first of all, I want to modify our Flask application. It's using application is down still. I want to change it to running. Let's run it again. And application is running. Okay. And after that, I want to create another application. I want to copy from app-1 to app-2. Let's open the new file. Let's change the name of the application from app-sync-phases-1 to waves-1. And app-sync waves. Very good. Let's apply this application, this new application. And this application has been created. App-sync waves-1. Let's click on sync and synchronize to sync the application. Health check is okay. And very good. And the last sync is sync OK. Let's click on sync OK. As you can see, the first resource is presync. So Argo CD will look at the phases first. This is the most important thing. But what about synced phase? Service account, service, and deployment are using the same phase. Their phase is sync. Service account is deploying before service, and service has been deployed before deployment. In this example, I want to replace the order of deployment of these two resources. I want Argo CD to deploy service before service account, for example. Okay, let's do that. I have a manifest called service.yaml. I open it. It has an annotations argo cd.argo-pro.io/sync-waves equals. As I said, the lowest number has the highest priority. Because of that, I define its wave number -2. Define sync wave for annotation for service.yaml. So sync wave. Yes. Okay. But what about service account? Service account has a default wave number. Its wave number is 0, but I want to change its default wave number. Because of that, I type again annotations argo cd.argo-pro.io/ sync wave equals -1. -2 is lower than -1, but has the higher priority than -1. I type define sync wave annotation for service account.yaml. Sync wave -1. Let's go to this application and sync it again. Okay, the last sync is sync OK. Let's click on it. As you can see, the service has been deployed in our Kubernetes cluster before service account in this time because of sync waves that we defined. If I click on service and if you see the live manifest, you can see that we have a new annotation for this resource called sync wave, and its value is -2. So we have another resource called service account, and its value is -1. Because of that, service resource has the higher value and has the higher priority to deploy in our Kubernetes cluster. This is how Argo CD sync waves work. Very good. Okay. In this time, I want to talk about the third priority in Argo CD. As you can see in this example, we changed the wave number of our resources, but the default number is 0 and this is 0. And let's replace these two resources, SA and SBC. These three resources in this example are using the same phase, sync, and they are using the same wave number, 0. In this situation, Argo CD looks at the third priority by kind. If they are using the same phase and the same wave, Argo CD looks at the kind of these resources, and Argo CD will deploy these resources based on their kind. Okay. I want to show you something. This is so important. Let's go to Argo Proj GitHub repository. I want to show you the source code of Argo CD. In this page, we have multiple repositories of Argo. It's different projects, argo-events, workflows, rollouts, and CD. We have another repository called GitOps Engine. Let's click on it. In this repository, we have a directory called pkg. Click on it. And in this directory, we have another directory called sync. Click on it. We have a file here called synctasks.go. Let's open it. I want to show you something. This is the source code of Argo. As you can see, we have a function here, and this is the variable called kinds, and these are the kinds that Argo CD uses. And these are based on the order. For example, service account here, this resource, service account has a higher priority than service. Because of that, if we have 3 different resources here, Argo CD will deploy the service account before service. Because of this, the kind of service account has a higher priority than service. For example, secret has a higher priority than config map. So if we have secret and config map in our resources, Argo CD will deploy secret before config map. You can use this repository to know about the orders of deployment in Argo CD. So it is the third priority, and it will be used when phases and waves are equal for multiple resources, like this. Very good. And the last priority is by name. In this situation, for example, let's imagine that we have two different service accounts. For example, in this in the resource path, we have two different service accounts. Their phase is equal, their wave is equal, their kind is equal. The both are service account, but in this situation, Argo CD will deploy these two resources based on their names in order. Very good. It was about Argo CD sync phases, sync waves, and the priority of deployment of the applications in Argo CD. Hope you enjoyed that, and I will see you soon.